right, starting out Unit 11, right? We're still dealing with rational things. So Unit 10, we talked about rational expressions, simplifying all that stuff. Unit 11, we're going to be graphing rational functions. So rational functions, again, dealing with their fractions, right? But issues with fractions is we have denominators, right? Denominators can be 0, right? Which causes some issues to be undefined, all those things. So when we graph a rational function, there are multiple what we call branches, okay? Multiple branches. So usually there's 2. We're going to deal with when there's 2, right? There could be more, but we're going to deal with when there's 2. Like we said, when we worked with expressions, we found restrictions, things that made the denominator 0. So same deal here. Those restrictions cause asymptotes. So those undefined values, those values that make the denominator 0, are called asymptotes. And there's 2 different kinds we're going to deal with. We're going to deal with vertical asymptotes, and we're going to deal with horizontal asymptotes. Okay? So vertical line, horizontal line. Now, with these, okay, we're going to deal with graphing things with a parent function first, right? And then we're going to get into more complicated ones as things go. So the parent function 1 over x, this is called the reciprocal function, okay? The graph of it looks like this over here on the right. So we have this vertical dashed line right here. That's our vertical asymptote. Okay. And then this horizontal dashed line, this is our horizontal asymptote. Okay. And then the 2 red lines over here, these are our 2 branches. Okay. So branch, branch. Okay. So we got that. Now over here we also see a couple points. We see a point right here at -1, -1, and we see a point right here at 1, 1. Okay? So we're going to be transforming these things, moving them up, down, left, right, stretching them, all those things, reflecting, flipping, all that. Okay? So we're going to be dealing with mostly this guy right here, this transformed version. So f of x equals a over x minus h plus k, which we have seen a, h, and k a bunch this year, right? So in this, h moves things left and right. K moves things up and down. And then a stretches, shrinks, reflects, okay? So in our case, what a is going to tell us, though, a is going to tell us how many units our points are away from the vertical asymptote, okay? So a is the number of units our points are from, we'll call them VA, the vertical asymptote, okay? So just by looking at this, by looking at a over x minus h plus k, we can determine the asymptotes and the domain and the range just by looking at it. Pretty simple, right? So the vertical asymptote is x equals h. Horizontal asymptote is y equals k. So whatever h and k are, there's our 2 asymptotes, all right? And then our domain is going to be everything except our h value. So we can use everything except that value of that vertical asymptote, and our range is everything except the y value of the horizontal asymptote. Okay, so should be, again, just looking at it, pretty easy to work with. Now, what we can work with here is the 2 branches, right? We can see of that parent reciprocal function, the branches are in the bottom left and the top right corners, right? Quadrants. So they're always going to be there unless the value of a is negative, okay? So that a negative a value is going to cause the graph to flip over the x-axis. So the 2 branches will be in the top left and the bottom right. So we're always going to be bottom left, top right, unless it's negative. Then it's going to flip, be top left, bottom right, okay? So they're going to be diagonal from each other every time. We just got to know where it starts. Okay? So, first thing, in these examples, it says identify the vertical asymptote, horizontal asymptote, domain and range, and then graph. So if we look at these guys, right, remember we are dealing with functions that look like this. A over x minus h plus k. So if we look at what we have, 2 over x. First thing here, a is 2, right? X minus h, there's nothing down there with x, so that means that h is 0, and there's nothing being tacked on added at the end, so that means k is 0, right? So we could say this thing is the same thing as saying 2 over x minus 0 plus 0, right? Same thing. Now, vertical asymptote is x equals h, so it's just x equals 0 for our vertical asymptote. Horizontal asymptote is y equals k, so k is 0, so y equals 0. Domain, x cannot equal h, right? So it's saying it can be every number except h. So x cannot equal h with 0. And then our range, y cannot be k. So it can be every number except k. So y cannot be 0. Okay, so what we do here, when we graph, we put our asymptotes on there. So a vertical asymptote at 0. So a vertical line going through x equals 0. And then horizontal, y equals 0. So horizontal line through y equals 0. Okay. Now we got to put our points on here. So this is where that a value comes in. So this a value right here tells us that our points are 2 units away from that vertical asymptote. So again, we're always bottom left, top right, right? Because a is positive. So bottom left, top right, right? So we're going to be 2 units away from that, from the horizontal asymptote, my bad. From the horizontal asymptote. I said that wrong up top. So from the horizontal asymptote, not the vertical asymptote. Okay, so we're going to be 2 units above and below that horizontal asymptote. So if we go 2 units, so if we start here, 2 units below, right, bottom left, we go here, and 2 units above, top right, we go here, and we're going to get close to those asymptotes, but we're not going to touch them. Okay, and then there's our graph. Now if we go in this guy, same deal, identify a, h, and k first. So a is negative 2, h, again, there's nothing down there, and k, there's nothing being added to the end. So our vertical asymptote, x equals h. Horizontal, y equals k. Domain, x cannot equal that h value, and y cannot equal that k value. So if we, again, put these horizontal and vertical asymptotes on here, okay, now what we've got to notice here is we have a negative, so that means this thing is going to flip. So now it's not going to be like the last one was in the bottom left and the top right. This is going to be in the top left and the bottom right. Okay, and then the 2 means that we're going to be 2 units away from that horizontal asymptote. So top left, we need to be 2 units away from the horizontal asymptote. So 2 units above, top left, draw in our branch. 2 units below, draw in our branch. Okay, and then that's what we're working with there. All right. Now, number 3, same deal. Identify a, h, and k. So this one, a is 1, h, so remember it's x minus h, so that h is a positive 4, and then k is 0. Okay, so our vertical asymptote, x equals h, y equals k, Domain x cannot equal that vertical asymptote, so 4, and y cannot equal k, 0. So horizontal asymptote at y equals 0. Now vertical asymptote at x equals 4. So x equals 4 would be here. Okay, and our a value is 1. So we are 1 unit away from that horizontal asymptote, and a is positive, so we're in the normal, bottom left, top right. Okay, so go from here, 1 unit away, drawing our branch here, and then 1 unit away, drawing our branch. So see something like that. Okay, in 4, same thing, a 3. This time there's nothing down there with x, so h is 0 and k is 5. So x equals h, y equals k, x cannot equal h, and y cannot equal k. So put these on here. So we got vertical at 0, and then horizontal at 5. Okay, and then for a is 3, so we're 3 units away from that horizontal asymptote, right? And again, it's positive, so we're in that normal bottom left, top right. So from there, bottom left, 3 units away, right here, drawing that branch. 3 units away up top, drawing that branch. Okay, so that's what we're dealing with there. Now, last couple, a, h, and k here. So a is -1, h, remember it's minus h, so that changed the sign, so that's a negative, and then plus k, the sign changed again, so that's -4. So vertical asymptote, x equals h, y equals k, and then the domain, x cannot equal -3, range, y cannot equal -4. So as we put these on here, x equals -3, so vertical line at -3, horizontal at -4. Okay, and we look at our a value, so it's negative, so again that means we got to flip. So now instead of bottom left, it's top left, and instead of top right, it is bottom right. Okay, right? So that's what we're dealing with there, right? So we look back at our -1, top left, bottom right, what we're dealing with there. Okay, and a is 1, so we're 1 unit away from that horizontal asymptote. So 1 unit top left, drawing that branch, and then 1 unit bottom right, drawing that branch. Okay, so that's what we're dealing with there. And then last one here, again, identify. A is 4, h would be +2, k would be +1. So x equals h for our vertical, y equals k for the horizontal. The domain, x can't be 2, and the range, y can't be 1. So vertical asymptote at 2, horizontal at 1. Okay, and then our a value is 4, right? It's positive, so we're in the normal, bottom left, top right. So we are 4 units away from that horizontal asymptote. Okay, so bottom left, 4 units away. 1, 2, 3, 4 units away. Let's draw in that branch. Okay, and then 1, 2, 3, 4. Drawing that one. And then there we go. Okay, so that's graphing the reciprocal function. Try out your homework. Let us know if you have any questions.